Okay, today we're going to finish up 6.3. We're going to finish up everything for this test, in fact. So I need y'all to focus. So yesterday we talked about it, but we didn't actually do it yet. But I talked about what happens. I kept making you do -0 for the axis of rotation when it was the x and y axis, because I said it's a placeholder. Eventually we're going to get to where your axis of rotation is not the x or y axis. Guess what? That's today. So it's discs and washers when the axis is something other than the x-axis. So axis of rotation, or revolution, rotation, is not x or y axis. It's like, what do we do in those cases when it's something else? Well, let's take one of the problems we've done before, and I'm just going to stick an axis of rotation out somewhere else. Okay, so from yesterday we had like 2 examples when we did discs. Now we're going to do, this is going to require a disc, but I can also do this with washers. But we're going to do this for discs, and then eventually I'll do a washer for you. So this is our first example, and I'm just going to do them because you just have to see how they fit together with everything else. Can everybody see this? Oh, I need to focus it. Go away. Better? Okay, example 1. So, this is going to be the region bounded by I got to do f of x equal to 4 minus x squared. What shape is that? What kind of curve is it? Parabola. Opens up or down? Down, and shifted up 4, right? Okay, that's really easy. None of these shapes are very difficult. We really like parabolas. Y equals 0, x is greater than or equal to 0, and revolve around y equals to -1. Did I pick something besides the x-axis and the y-axis to revolve around? Okay, one of the things I need you to realize is y equal to -1 is a horizontal line. Because y'all know, so remember. Here's the way you think about it. The way lines work, if there's an x and a y in the line, it crosses both axes. If there's only a y, it only crosses the y-axis. If there's only an x, it only crosses the x-axis. Did anybody ever tell you that? Okay, so since it's y equal to -1, it's a horizontal line. So what's that parallel to, x or y-axis? It's parallel to the x-axis, and if everything's revolving around it, are all my cross-sections perpendicular to the x-axis? Okay, so what's it going to be in terms of? But the scary thing is that on Friday it will not be so funny. Okay, so since it's a horizontal line, it is parallel to x-axis. I can't write. You have me so panicked right now I can't even write. X-axis. Therefore, it is with respect to x. We already know that. It's with respect to x. So we need everything in terms of x's. And it's already solved. Y is equal to x, and we're good. So now we just have to sketch this thing. And we've already gone through this. It's a parabola aimed down, shifted up 4. Surely you can graph that really fast. Make my x and y axis. And I want to go up 4, so 1, 2, 3, 4. I'm going to start up here. And I know because I was an amazing Algebra 2 teacher, opens down, I got to go 1, down, I could go over 2 down 4. Oh, there's my region right there. Why do I know that? Because they told me that I was doing this around y equals 0. Well, this is y equals 0. Right? Oops, I need a red. Hang on, red. There we go. This is y equals 0, yes? That's part of my region. And then another part of my region is x is greater than or equal to 0. So is it all of the x's this way? So is that really a boundary? Is the y-axis also a boundary? X equals 0. Is that another, when I say x is greater than or equal to 0, is that the same as saying that the y-axis is, the region we're talking about is bounded on the left by the y-axis? Is that another way to say that? Did y'all catch that? Is it bounded? Here's my region. Let's draw the parabola. Do y'all see the region yet? Because I don't think some of y'all see anything. Okay, it's not over here, is it? Because they said all the x's this way. Another way of saying it is, I'm talking about this region right here. And that region is bounded on the left by the y-axis. It's bounded below by the x-axis and bounded above by the parabola. Are those words the same thing as saying x is greater than 0, y is greater than 0, and it's underneath the parabola? Are there many ways to say it? I need y'all to read for content. You're looking for the words that are describing where the region is in relationship to other equations, like x equals 0, y equals 0, and y equals 4 minus x squared. So everybody see the region? Yeah? Okay, that's the region we're doing, and we need a line at y equal to -2. So my axis of rotation is 1, 2, it's down here. Oh, it's -1, sorry. I was doing my example from yesterday. Oh, well, here it is. Y equals -1. Is that my axis of rotation? So draw the little arrows showing it's curling around it, right? Does that mean my cross sections are vertical because they're going around a horizontal line? So that means I got to draw in my cross sections. Are they like this? Notice I did not. That's my region. It doesn't go down here in this gap. Uh-oh, it's a gap. Is it a disc or a washer if it has a gap? Washer. Oh. Is light bulb coming on?
Yes.
Look! Between my axis of rotation and my region, there's a gap. Okay, so now what we're going to do is we're going to go draw in. Start at the axis of rotation. Start at y equal -1. Go up until you reach the outermost curve on the region. What did I just draw in? Big R. That's big R of x. And what is big R of x? When you're doing big R of x, do you then, once you've identified it's the big R, then you do upper minus lower. What's the upper curve? What's the lower curve now? So minus a -1. Remember how I kept saying put the -0 as a placeholder? Oh snap, is this y? Yeah, it is, sorry. I'm doing the next problem, sorry. X, thank you. Okay, so what is this? That means, is that going to be 4 plus 1? So does my big R equal 5 minus x squared? Okay, so that was, let's do another funky color. Oh, I want orange. All right, now start at the axis of rotation again, only now go to the lower boundary. Is that little r? And it's the gap. The little r is the gap. So what is little r of x? 0 minus a -1, which is equal to 1. Does that make sense? The radius is 1 because it's a flat right there. The reason we're rotating is flat. So is it going to have a radius 1 the whole time? So it truly is a cylinder. The whole thing's a cylinder. Way cool. You could even work it that way if you wanted to. Do you realize that? You could use geometry instead of calculus. But we're going to do with calculus because we're just going to practice for when it's not a cylinder. Okay, I've identified big R, I've identified little r. Now I just use that formula we learned yesterday. So from yesterday, we go back to my volume is equal to pi. Oh, I forgot. What are my limits of integration for this?
0 to 2.
0 to 2. Because my A is 0 and my B is 2. He's making me feel better because he's making up for it. That's wonderful. Okay, is it going to be big R squared, which is 5 minus x squared, minus little r squared, which is 1 squared, dx.
Más simple.
Más simple.
Cecil.
I'm not sure what that flag is. Might be Portuguese. Something like that. It's definitely Latin based.
Yes.
I can get that far. Okay, so would that be, by the way, would you have to do algebra here? Because U sub is not going to work. I mean, but you're squaring things. Can y'all square binomials? Please, well, please try. Okay, I'm not worried about the calculus on this. Shh, believe it or not, because are these things relatively simple to integrate? They're not the tricky U sub ones. So it's polynomials in general, because I don't want to do anything else with y'all just yet. You see what I mean? I don't want to do anything else. This is enough. This is enough. Yeah? Yeah, okay. Okay, now I need to show you another example because that's, so far we've always been doing something minus 0 or something. I have another thing. I want to do it for you because even though it should be straightforward, I see y'all making a mess of it. I see you following a fine tradition of all my students messing this up. How's that? Because it's different. So we're going to stop. We're going to like kind of nip that in the bud now. Here's example 2. It's just like that one, only ever so slightly different. And I want to see what y'all do with it. So now, instead this time, I want you to find, we're going to take the region defined by it's going to be no, this time it's going to be y equal x squared, my favorite function, one of my favorite functions, right? It's going to be x greater than or equal to 0, and it's going to be y equal to 4. Those three things are bounding it. I'm not going to tell you how. And we are going to revolve it around y equal to 4. So let's see what that looks like. It's really, it's x squared, x equals 0, and y equals 4. Surely we can graph those. Yes, we can. I know we can. I know y'all can too. 1, 2, 3, 4 for a reason, right? 1, 2, 3, 4. All right, so I'm starting at 0, 0 because I'm drawing the x squared first. Oh, I'm going to do it in red. So x squared starts at 0, 0, right? And then 1, 1, and then 2, 4, right? So that's my parabola. And I'm going to only draw this because they said that x was greater than 0, right? So I'm only doing the positive arm of the parabola. X equals 0 means that this is also a boundary because I want all positive x, so x equals 0 is another boundary. So it's bounded on the left by x equals 0. It's bounded below, I know it's bounded below, by the parabola y equal x squared. And then there's the line y equal 4. And I did this all in red so that you could really see. Those are the three things. Can you see the region between them? I'm serious. Can you really see it? Because if you can't, we have work to do. Is it this region here? Yeah, it's that region there, isn't it? And I am revolving this around y equal 4. Is y equal 4 parallel to the x-axis? What's this going to be with respect to? Yes. So this means with respect to x.
I sure did.
Jeez. Always causing trouble. Oh, on that last one, I forgot to draw the cross section. We need to do that. Oh wait, I don't want you in front. I want this in front. Why is it doing that? Okay, I'm gonna make that go away. Go away. Stupid stuff. All right. Are those my cross sections? Now I want to draw I didn't draw the cross section before. I want to draw it so we can see the gap and make sure everybody sees it. Notice on this, my big R went like this. That was big R, and then my little r went like this. So there was a hole in it. And then there was a disc, right? So it's clearly there's a hole because of that. Look down here. If I take this one cross section right here and draw it right here, does it touch the axis of rotation? Does it touch the axis of rotation everywhere? Then it's a disc. Is that a disc? Do you see why I want you to draw the typical cross section? Because I want you to tell the difference between a disc and a washer, because I'm not going to tell you. You have to figure it out. This is a disc. Clearly looking right here, that's a delta x, right? This is r in terms of x, yes? Now, to find that r, do we have to do upper minus lower? What is the upper curve? So it's just 4 minus, what's the lower curve? What's the lower curve? X squared. Is that my radius? Yeah. And so there is no gap, there is no hole, it's just a disk problem. No little r. Because it touches, if the region touches the axis of rotation everywhere, there's no little r. If there's a gap between the region and the axis of rotation, there is a little r. You see what I'm trying to emphasize for you? Because what my problem is right now, y'all can't see this yet. You see it. Okay, going to the next page. Can we write the volume now? So volume equals pi. I didn't do my limits of integration. What are my limits of integration for this? 0 to 2, right? That was easy. 0 to 2 of my r, which was 4 minus x squared dx. You can't do that with u sub. So you're just going to actually do algebra. What's 4 times 4? It's 16. And then 4 times the negative x squared is going to be, 2 of those is going to be a negative 8x squared, and then squaring that is going to be a plus x to the 4th. Why am I not worried about the calculus? Because when you get to a polynomial like this, if you can square binomials, please practice that. Without messing up, is the calculus easy on this? The hardest part is setting it up. So am I going to give you points on your test on Friday? Am I going to give you points to draw me the picture? Am I going to give you points for labeling R, labeling the axis of rotation, drawing me a cross section so I can see that everything is with respect to X? Because if you do that, then you're going to get it right. And if you don't, it's a gamble. And I don't like to gamble. I understand the odds with y'all. All right. Is that easy to integrate? This one we're actually going to integrate just for giggles. Pi. What is the antiderivative of 16? 16x. Minus. What's the antiderivative of 8x squared? 8x cubed over 3. What's the antiderivative of x to the 4th? 5th over 5. And I am evaluating from 0 to 2, so it's not bad. It's not hard math. It's not hard at all. So pi, when we multiply times 2, is at 32 minus what's 2 cubed? And what's 8 squared? 64 thirds. Plus what's 2 to the 5th? 32 fifths. It really is. All right. Well, if this is on the test and I don't give you a calculator, you get to stop there. All right. But wait. Have we done anything with respect to y? Oh, it's also minus 0. Do you need to check? For polynomials, I'm not so concerned. If there's trig, you better plug it in, because y'all are lousy at trig. Just saying. Okay, so last example, we got to do something with respect to y, yes? We do. Okay, so with respect to y. This is an example, what are we at? 3, thank you. I lost count already. This time, I want the region between I want it between x equal y squared, ooh, and I want x equal to 9, and I want y equal to 0. I want the region between there, and I want you to revolve it around x equal to 9. Easy. Really easy. So, is this a sideways parabola? Yeah, sure it is. So we can do that. Everybody write down what we're doing. X squared, x equal y squared, x equal 9, and y equals 0 revolves around x equal to 9. So what does this look like? Let's draw the picture. Oh, I want that down here. Hang on. I want to make it nice and big for you. All right, so I'm going to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't have to draw it to scale. You could just swag it. That would be okay. But I'm not going to. I'm going to exaggerate my vertical scale. Ooh, that I just made go away. Hang on. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I'm going to exaggerate it so that it's easier to see. To 1, 2, 3. Yeah? Okay. I go to 0, 0, so it starts at 0, 0. I go up 1, so I put in a y of 1, it's 1 squared is 1. I put in 2, it's 4. So hang on, that's not 1. This is 1. And then 2 is 4. 1, 2, 3, 4. Because I exaggerated my scale. And then if I go to 3, it's 9. Right there. So is this the parabola? Sideways parabola. That is x equal to y squared. This is y equal to 0. And then this is x equal to 9. Could they also have said that it was bounded on the right by x equal to 9, bounded below by y equals 0, and bounded above by x equal y squared? Same words. And what am I revolving around? I'm revolving around that vertical line. If it's a vertical line, all the cross sections are perpendicular to it. So what is this line parallel to? The y-axis. So what does it have to be in terms of? Y. We're going to draw our cross sections in. Here are our cross sections. Like so. This is the region, right? I'm revolving this region. Does this region touch the axis of rotation everywhere? Do y'all see that? Let's draw a typical cross section. We're going to do this one right here. This is going to be our big one right here. If we do this, we come down here and we draw it in. Does that mean I have a disk? My big R is with respect to y. There is no gap. There is no little r. If I look down this way, is that a delta y? Am I stacking disks? Stacking from y equals 0 to what? 3. So is my C going to be 0 and my D equal to 3? Are those my limits of integration? Because that's the y values I'm stacking my disks in. Yeah? Okay. So what is big R equal to? Big R is a function of y. What's it equal to? 9 minus y squared. Because this is x equal to y squared. This is 9. 9 minus, because I'm doing right minus left. There is no little r. So you're ready to write the equation, right? Is it that simple? You too can make these that simple. Is it going to take practice? Okay, I'm kind of out of room, but I'm going to write it. I'm just going to write it right here because it's really not, it's not complicated. What is my volume equal to? Pi what? Integral from what to what? 0 to 3 of 9 minus y squared dy. Is that easy? Is that really easy? Okay. The integration, you have to practice squaring binomials, but other than that, is the calculus easy on these problems? If it's hard, you've probably done something wrong. No, because my axis rotation is the 9. Is that why? That's why we're doing this, because that was my placeholder. It's gone. And instead of being minus 0, it's the other way around. It's 9 minus, because when we get off that axis rotation, now I can do all kinds of fun. All right, stopping.